Welcome to Coding Adventures, everyone. Today we are starting a new and interesting lesson in JavaScript, and we're going to be talking about for loops in JavaScript. So this is all about how to repeat things in order not to type them manually, but let the computer do the hard work for us. So let's get started. Alright, so here I am in our favorite coding editor, and here we're gonna learn about the for loops. Last time we talked about variables, and that was the very first, let's say, deep incursion into JavaScript syntax. Today we are talking about for loops, and for loops are all about repeating things. So let's first start with an example to see how to do things without a for loop. Okay, perhaps we want to print a message several times. To do that, of course, we can use the println instruction here in the codegapi.com environment. So let's write here, hello world. And if we want to print this like 10 times in a row, we can just copy and paste the instruction. And when we're gonna run the program, of course, we have hello world. But what if we want to run this 100 times? What if we want to display this 100 times? Well, that's also easy. So we have 10 instructions here, 20, 30, 40, 50, 60, 70, 80, 90, 100. Wow, we have 100 instructions. Let's run them. And we have hello world printed 100 times. Well, this looks quite easy. What about printing 10,000 times? All we have to do is multiply this 100 times. Well, I think that's not a good idea. So perhaps we should learn about for loops. So let's remove all these instructions and keep just one. And now, what are for loops? As I mentioned, it allows you to repeat things. And let's start by making ourselves a goal, and let's repeat this instruction 10 times using a for loop. So I'm gonna type the instruction here in the code. It's actually not an instruction per se, but it's a JavaScript construct. I'm going to type it in, and then we're going to understand what it does. So the syntax is this. Let I equal 0, I less than 10, I plus plus, and just like that. So let's run it. And as we can see, we have hello world displayed 10 times. Now, what about if we want to display two messages together 10 times? Perhaps we should also display here something such as hello. Can we display these two messages, hello world and hello, together 10 times? If we'll run it, we'll have a surprise. Hello is just displayed at the end. And the reason for this is because white spaces we discussed, they don't matter. So this instruction is executed 10 times because it's under for, but this one it's just sits alone at the end of the program. For now has another way to basically make this instruction execute together. So this block of instructions, we want to repeat them 10 times. And the way to do that, we're gonna put them in curly brackets. And just for beautification, we're gonna just indent them a little bit, move them a little bit to the right. That's a common technique, and it's a good practice. But again, the white spaces, they don't matter. So now we are looking at this instruction or construct. We're gonna run it, and we see the two messages being repeated together 10 times. And now it's time to analyze what we have here on the screen. Okay, so I'm gonna grab my notebook here, and as always, we're gonna deconstruct this construct, the for loop construct. And let me switch to the notepad here, and let's write it in text. So what we put in there, we put a for, and this is the name of the construct. And then we have a parenthesis, and inside the parenthesis, we wrote these pieces of text. Let I equal 0, I less than 10, I plus plus. And then we have a curly bracket here, and then ending curly bracket here. And here in the between, we placed some other instructions. In our case, we placed println. And at a glance, this one is doing what we said. So it's repeating these instructions. Basically, these ones will repeat 10 times. So this was the effect. It's like we would have written ourselves println and the other one together 10 times. So how is this working? Well, it's due to the syntax of the for instruction here. And if we take a look inside the parentheses, first of all, we see here the first part here looks like a declaration of a variable, and we learned about declaring variable yesterday. Here we see that we see a comparison basically. We see that I is compared with 10. So we are assuming that basically this will be repeated as long as I is less than 10, and then we see I++, which is an increment. So the way it's working basically, and in technical terms, this is the initialization part of the for, this is the comparison part, and this is basically it's a statement that is executing after each condition. The way it's working is basically JavaScript is creating here inside the for a variable. It's naming that variable I, and then I is increased for each iteration with 1 until reaches 10. So basically this is what is happening. JavaScript is first thing is creates I, and actually it's not JavaScript that creates I, it's us that we declared it inside this declaration part of for. And then for each iteration I becomes its increased until I basically becomes greater than 10. Or this one works as long as I is less than 10. Well, it's a lot of things, and it's a little bit difficult just to understand this format in the beginning, but fortunately there is a very simple way to learn for. In the beginning, we're gonna put here on paper a few forms of for that you can just learn them as is, and in time you can extend them. And I think today I'm gonna show you 5 forms of for. Is no more than 5, and if you just write this down and if you just copy and paste them as is, you'll be able to achieve pretty much everything that you want. It's very rarely you go beyond these 5 forms of for. Okay, so let's run this program again to see the effect. And basically this is a use case of for, to repeat certain things multiple times. Okay, so let me start a new page here, and I'm gonna maybe I should just draw a table here. I said there are 5 use cases of for. Maybe I should put those use cases here. So yeah, maybe I should just start from the beginning and put number here, and then use case to say like that, and then here we're gonna write the form for the use case. So here will be the code. All right, so the use case number 1 here is repeating a block n times. And the block, by a block we mean a block of code that is basically we can define between curly brackets. So if we place multiple instructions in between curly brackets, like we have here, let's take a look at these instructions placed between curly brackets. These form a block of code, and this block of code just behaves like one instruction. And this is the beauty, because we just group them together. It's a group of instruction, this block of code. So if we have just one instruction, we can place it directly under for, like we saw in the beginning. But if we have more than one instructions, we always have to just group them with curly brackets and define a block of code. Now, even for one instruction, it's sometimes recommended just to define a new block and place that one inside. So even if we don't have the second one here, it's a good practice, because if we want to add the second one later on, we can just add it here without having to just introduce new brackets and so on. So this is the first use case. We want to repeat an instruction, like this case, print hello world, and we want to repeat it n times, in this case 10 times. So the form for this one is basically like we see it here on the screen. We have it for, we define a variable, and the variable name, it doesn't matter. And not only that, it doesn't matter, but we are not even use the variable. So you choose whatever name you prefer. I choose I, that basically stays for index. Here we put I less than 10, I plus plus, and 10 is our n. And then open and close curly bracket. So if we want to repeat certain things several times, this is the form for this one, as you can see it in here. So you just use for, type it exactly like I'm writing here, or like you saw on the screen. The only modifications that you need to do is basically the number 10, which is basically your only customization here. And perhaps we should just mark that one. So this is the only thing that you want to eventually modify. So if you want to display this 10 times, put there a 10. If you want to display 100 times, put 100. So let's go switch back to the code, and we'll put here 100. Boom. Here, I'm pretty sure we have 100 text hello world. So this is a use case. We want to repeat these things 100 times. So basically, in plain English would be, unfortunately, we don't have an instruction, a simple instruction just to say repeat 100 times and then to tell it what to repeat. We don't have that one. We have to write this pretty long and weird looking syntax to repeat things 100 times or 10 times, or maybe if you want 5 times, we'll run it just like that. So it's 5 times. Notice we are starting at 0 here. Always don't change this part. If you want to repeat a number of times, let's say 5 times, start at 0 and then put the number that you want here. And there is a very simple explanation, because because it starts initially at 0 and it works until it's less than 5, so it will take the number 0, 1, 2, 3, 4, which are basically the whole 5 numbers. But as you can see inside the code block here, we are not making use of the I variable. We are not printing the I variable. We are just repeating something that we want 5 times. That's it. So that's one form. It's repeat things a certain number of times. And again, write this down somewhere, exactly this part. Eventually you can write the entire snippet with a println inside, but this is, you can place whatever you want here inside. You can repeat perhaps a circle, and we'll see it later in today's lesson, repeating also graphical shapes. But for now, write this form down is very important, okay? Let's see use case number 2. Actually, we'll leave them all inside here, because I'm gonna share this. So for let's just name it 4. It's a very simple name. And why not? I'm gonna share this one on the chat in the beginning. So let me put it on the chat. 4. If you want, you can open it on your side and play with the code. So look what I'm gonna do. As I'm gonna write more code inside this file, I'm gonna save it, and if you just refresh that page of yours, you basically get a new version. Okay, so let me comment all together this code. I don't start a new file, I leave it here, and I'm just going a little bit below that one. So another use case is maybe we want to make use of the I variable inside. So let's make an example. Let's print quickly numbers from 1 to 10 on the screen, okay? So again, print numbers from 1 to 10 on the screen. Before that, let's leave a comment here. Repeat a block, let's say 10 times. That was the initial example. Now let's do another one. Print numbers from 1 to 10 on the screen. On the screen, it's enough to say like that. So we're gonna use again a for. And let's try to use it as above. I equals 0, I less than 10, I plus plus. And there is a very simple difference from the above example. We'll just say here, print a ln, and instead of a message, let's display the I variable itself. So in other words, we are making use of the I variable that is defined inside the for. We are making use of it inside the block of that for structure, okay? So let's run this one. And we see here 10 numbers, right? But the numbers start from 0. And the reason it starts from 0 is because we said to start from 0. Well, so how can we, so if we run it, it displays from 0 to 9. If we want to display numbers from 1 to 10, there are multiple ways of doing it. Actually, let's see, one way is actually to add 1 here. So since numbers starts from 0, we shift them a little bit. So in the display, we're displaying from 1 to 10. Let's run them. And as we can see, they are just displayed from 1 to 10. Another way of doing this is, and let me comment this out, and I'm gonna duplicate it. So we're gonna leave the number here, but why not start this number here like that and go here up to less than 11. So basically numbers will start at 1, but they are less than 11. And now we see them correctly, 1 to 10. And we didn't have to add here a number inside. And so that's another form. Let's comment this out. I want to show you another form. So another form would be, we go up to 10 here, but instead of saying less than 10, we say less and equal than 10. So like in math, you probably remember in the math, the symbol for less than equal. Well, in JavaScript is this one. They are two characters. There is a less character and an equal character. Together, with no space in between. So if you put a space, will not make sense. So together has the meaning of less or equal than 10. So if we run this one, again, we see the numbers from 1 to 10. Okay, so perhaps this is the form that we want to write on the paper here. Let's switch to the paper here. The other use case here would be basically, or not use case, maybe I shouldn't name this use case. Use case is a pretty bad name to choose for this one, but it's basically another form of for that I want you to remember is basically this one. It's the same as above, but I'm gonna write it here with also starting at 1, just to see that we have also this option, less than equal with 10, I plus plus. And this is another important form of for that we want to remember. And the difference from the above is actually making use of I inside here. So here we didn't make use of I, but in this form I'm showing that it's also possible to make use of I inside. All right. So, and also notice again, here we want less than equal to. So basically, let's write here some text, making use of for variable inside the block. Okay, so this is all about making use of this variable inside the block, right? And to use it like that. And basically in our example that we put here on the screen, we use this form, we use the println instruction, and we made use of the for. And it's like, you know, if we don't use a for to make use of a variable, to be like defining a variable, having a value, reassigning a new value, and do some action, reassign a new value, do some action, but for is doing this for ourselves. So just, you know, just for understanding, I'm gonna write here what would be if we don't have for, and if we want to write the numbers from 1 to 10. So probably, of course, one format is to use just to write like that. But this is not what for is doing. For is basically doing is like having a variable that is initially 1, is printing I, and then is making really quickly I plus plus, and is printing I again, and is making really quickly I plus plus again, and is printing I again, and is doing this up to that number that we put there. So basically it can be 10 times or whatever number we put there. So if we run this program, let's make sure, yes, we commented things above. See, we have numbers up to 6. So basically we display this probably 6 times. So this is what for is doing, but it's not duplicating the code. We basically write just println I inside the for, and the for is doing the heavy work for us. So in a sense, if I'm gonna switch here again, this is like the entire thing here that we did is like declaring a for, and for starts at 1. It's basically printing I, this variable, then I becomes plus plus, it's incremented, and is going back to here, how many times? 10 times. So goes back here 10 times. This is why, oops, I don't think you can see this one. This why it's called a for loop, because it looks like a loop here. It's a repetition structure again, and this is what's happening inside for. In internals of JavaScript, a variable is defined, the one that we define actually ourselves, then the block is executed, variable is incremented, or this block is executed, and then the entire thing is repeated 10 times. And this is a very good use case if we want to basically iterate quickly through a series of numbers from 1 to n. We can do it in this way, or if we want to iterate from 0 to n, it's basically doing this way. All right, so these are 2 important use cases. Let's see, well, you may say, so let's leave this one uncommented, the last form uncommented here. Let's make sure it's running fine. Yep, it's running fine. So what about if we want to display all the even numbers? So in other words, we want to basically display the numbers from 0 to 10, but just skipping one number. So the way to do that, we can also use a for. So let's comment this out now. Let's put a comment above and say display all even numbers. And the way to do that, we also use a for like we used before, but the difference is that will not increment by 1 but increment by 2. So let's do this really quickly. Let's say let I equal, we start at 0, we go as long as less than or equal than 10, because we want also to capture 10 in this case. And now the difference here, we increment by 2. And we saw the this incrementing form in the lesson from yesterday about variables. But this is a form, this is another use case or form of for that it's good to remember. Just write it down. This is the third form that we said there. So let's display here I, and if we run it, yes, we can see these numbers. So let's go up to 100. Yeah, we can see all the numbers from 0 to 100. And this, let's change this one by 5. See, now it's like we are stepping. So this is a form of stepping from a number to a number using a certain step. So we have 5, 0, 5, 10, 5, 15, 20, and so on. And all we had to do as different from the above is instead of incrementing by 1 I, we are incrementing I by 5. Again, this is another form of for that you should just remember it as is. It will make more sense later on. If you try to just really rationalize this one at this moment, it may be not necessary, but if you just want to know a quick way to iterate through a series of numbers, perhaps even stepping to these numbers, you should remember this form. And actually, let's put this form down in writing here. So the other form would be, we are interested in, we have a new page here, we are interested in a way of saying for from 1 to n, stepping every I don't know, X steps. So the way we do that, we say for, we choose a variable let. We can choose whatever variable name we want. I choose I. It's a common practice for generic variable that iterates to some numbers to choose letters such as I or J. It's a common practice, but you can choose X here or A or B. Actually, let's initialize the variable with a certain number. So perhaps we want to iterate from, here I said 0 in the code. We can put 0, 0. The second part here, it's exactly like above, is the to part. And then here we put a step, plus equal 5, we said there. So again, this is the from, it starts from, goes to 2, and this is the step. Yeah, perhaps this is the easiest way to remember this one. If we want to go with an I variable from a certain value to a certain value with a certain step, this is the way to write it, right? Or to remember it. And here we have 5, and this is another number to change, and 0. And here also the operator through which we increment. And it's working, actually it's working fine. We put plus plus before, but if we put here, if we don't use this form to increment by 1, we can also use the +1 form and put here 1. And if we are running this one, well, we see all the numbers from 0 to 100 because we put less than equal here. So it's common when we increment it by 1 just to use plus plus. It's a shortcut, and if you increment by more than 1, use this other form. Alright, so we should remember this one as well, and as you can see here, we displayed all the even numbers, or in this case they are not even anymore. Even would be this one, if we stepping by 2, yep. So what about counting down? What if we want to count from a certain value down and display all the numbers? So let's do that exercise as well. Counting from n to 0. And actually you can stop at any number in between. We don't have to go down to 0. We can stop in between, but let's say to 0. And the syntax for that is very simple. We just use let I equal, not 0 this time. Perhaps we want to count down from 10. And is working, the for is working as long as I is greater or equal than 0. And then we put here I minus minus. Okay. So let's read this again. I is starting at 10. The loop is working as long as I is greater or equal than 0. And for each iteration, I is decremented by 1, I minus minus. So the number should go down. All right. Let's display I. And we have the numbers displayed, right? Well, let's write this down as well. So I'm gonna prepare here a new line. Just take your time and inspect it on the screen meanwhile. And basically, this particular use case is basically we want to iterate. So it's from n down to 0, stepping. And stepping is negative, so basically we go by -1 stepping. So let me show you what I'm writing here. All right, so the form would be for let I equal 10, I greater or equal than 0. Because the way JavaScript evaluates here, it says as long as I is greater or equal than 0. We'll do the loop, and then for each iteration we're decrementing the variable, and inside here we have whatever we want to do, so like printing, right? And it's the same basically. If we want now to, let's say we count down but with a certain step. So let's count down with a certain step. Oh, I just created an empty block. So inside the same one here, let's write for, and let's start let I equal 10, and perhaps we want to display the even number but counting down. So as long as greater and equal than 0, and we are just using minus equal, right? Like we saw yesterday, as expected. And let's say use a println I. We can leave also the above here in the code. They don't interfere one with each other, but the display will be a little bit crowded. Let me show you. So basically this is the first list, and then this is the second 4. And in the second 4 we can see that it starts from 10 and goes down to 0, stepping with a step of -2 basically. So let's comment the other one. All right, so this is how many forms did we write until now? I said I'm gonna show you 5 forms, and I think I showed you, well, considering this one, I think this is the 5th one. If we consider also this form when we're stepping down, so let me write it down again. So it's basically from n down to 0, and the step this time is not -1, it's a negative -x, an arbitrary -x, and the format for this one is for let I equal n or 10, I greater than or equal than 0, and then I minus equal x, or maybe we should go by 2, just as for example. Okay, so this is the third form. Oops, you're not seeing you're not seeing the form here. All right, so these are the 5 forms of 4 that is good to remember them, and in the beginning is good just to write them down somewhere and use them whenever you have a need for 4, and in time you'll just create them naturally without having to make reference to your notes. So let's put this kind of comments also above here. Although we have some comments here, let me comment all together the code, and actually let me uncomment this one and let's repeat it. So first of all, we said we want to repeat the block 10 times, right? So this is the way we do that. Let's separate these blocks with println, and let's separate, we want to run them all at once now. Repeat the block 10 times. Perhaps we should just put here println what we want to display in here. Repeat a block 10 times. And we don't need a comment above, or we can leave the comment as well. Okay, and then we start the second part here. Print numbers from 1 to 10. This is what we want to do. Let's put a println above and just copy this comment and use it inside println. Print numbers from 1 to 10, and this is what we have to do. This is another form. Print numbers from 1 to 10. Let's copy this line. It's another form, and this is another form. So we have 3 forms. So perhaps we should say here first form, second form, and third form of printing numbers from 1 to 10. Let's scroll down. All right, we go in the other block. Perhaps we should say here println the same comment. Just bear with me a few more minutes until I finish placing these println instructions inside the code. And this goes into the other block. Perhaps we should have a println as well here. And the block, and we have 1 form and 2 forms here. So from n to 0, and here is from n to 0, stepping by -2. All right, so I remove all the other comments. Let's run this. And now if we'll run it, we'll be able to see, oh, let me place also the minus in between. Just bear with me one more second. So when we go into the next block, let's have this kind of separation. When we go into the other block, we'll put again this one, and that's it. All right, let's run them. Everything in one program. First one, repeat the block 10 times. We have the repetitions. Then we are displaying the separator here. print numbers from 1 to 10, the first form, and we see the numbers, works correctly. Second form, print numbers from 1 to 10, correct, displayed correctly. Print numbers from 1 to 10, this is the third form, not fourth form, we should correct there. And we see them correctly. Display all even numbers, and I think we're displaying up to 100, we see them correctly. Counting from n to 0, in our case from 10 to 0, and we see them correctly. And then counting from n to 0, stepping by -2, and we see them correctly. All right, just correct this one. Here it's a 3, and then perhaps we can put them, so this separator before this one. All right, so I'm gonna save the program, and this is the same program that I placed before on the chat. If you'll reload the window, you'll be able to see it on your side, and I zoom out a little bit just to see it. It looks like a long lines of code, a lot of lines of code, like 60 lines of code, but these are just the same structure repeated again and again and again. All right, so I feel that we need to repeat one more time this these 5 forms of for, and basically let me write them down succinctly, just what we did here. Without writing the forms, we're gonna repeat them we're gonna look at them in the code, and then we're gonna move on to create some exercises using for. All right, so the first things we want just to repeat first form. Oh, let me switch to this camera. Repeat n times. If we want to repeat something n times, and we have a solution for this one, we're gonna check it in the code. The second form or use case that we want to remember is to basically iterate to some numbers, starting from a number, perhaps 0, to another number, let's say to 10, and that's it. And we have an example about this one in the code. The third form here is we want to iterate starting from 0 or a certain number, we go up to another number, maybe 10, with a certain step, with a step of 2 perhaps, when we display the even numbers. And we can do that as well. So this one is just repeating certain things n times. We don't care about keeping track of the number of the for variable inside the block. This one is just displaying numbers such as 0, 1, 2, 3, and so on up to 10. This one is displaying basically the same, but using the step 0 to 4. The other form that we saw today was to basically exactly like these two, but going down. So we start from n, let's say 10, down to maybe to 0. That is the opposite of this one, so it's going in the other direction. It's like 10, 9, 8. We saw how to loop through these numbers in this way. And the other form that we looked at it today is basically with a step, going down with a step. So perhaps from 10 down to 0, let's say, with a step. I'm gonna write it here in pseudocode like that, with a negative step of -2. And we have a solution for this one. So perhaps like going like 0, 8, 6, and so on. All right, so these are the resumed again the 5 forms of for that I mentioned to you. They are pretty important to remember. They are all written basically, they are all created using the for instruction, here by creating a variable. And just for reference, I'm going to use for this one or this one, the first form, I equal, we start at a certain value, we compare the variable with the value where we want to go, the 2 here, and then for each iteration we basically either increase or decrease variable. So exactly in the form that I wrote it here, it matches the scenarios 1 and 2. So basically this one is 1 and 2, but we put there in the code as well examples for the other forms as well. So at the end of the day, for loops are about looping a variable. You take a variable that has a certain value and you want to loop it actually through a series of values. So either going in ascending order or descending order using a certain step. So these are basically the most common ways in you can use a for loop. All right, I think it was a little bit of a lengthy explanation than usual. I hope you're still watching this stream. So let's do some exercises with for. Let me go quickly outside of this one and go in a code editor. And as we do more exercises with for, we'll be able to just understand better the for loop. So let me repeat one more time one exercise, counting from 1 to 10. Okay, it's very simple. For let I equals 0, I less than 10, I plus plus, we close this one, and basically this is the from that we said there, from 0 to 10. And now here let me use also println. I'm gonna just display I for the moment, but that's not the purpose of the exercise. All right, the for looks correct, it displays the number. So the exercise that I want to do is basically, and I'm gonna put here as a comment, calculate the sum of numbers from 1 to 10, or 0 to 10. Yeah, it should be the same. Adding 0 to something should not matter. All right, so how can we implement this exercise to calculate the sum of numbers from 0 to 10? And as a hint, obviously using a for loop. And it's not that complicated, okay? So all we have to do is to imagine we are looping through all the numbers, and as we're looping through them, instead of displaying them like we displayed them before here, so instead of displaying them, we want to basically put them inside the box, add them inside the box, right? Add them all together. So we are looping, you know, once we reach 0, we put it there in the box. Once we reach 1, we put it there, and so on. And adding them all up inside the box, at the end of the day, at the end of the iteration, not day, inside this box, we're gonna have the sum of numbers. And what better way to create a box than a variable? We just compared yesterday variables with boxes. So let's declare a variable, and it's very important now. We're gonna declare the variable outside of the for loop, and let's say the variable is 0. So this is our box, and the box is 0 initially. And the way we are declaring outside of the for and not inside here, so for instance, what will be the difference if we declare it here? Well, because for is a repetition, this declaration will just repeat, but we want the box to create it once. We create the box once before we start to looping through the numbers, and then inside here, what we're gonna do, we're gonna add to the sum a number, and the way we are adding it, it's using this form we saw yesterday. If we want to increment the sum a number with a certain number, we add I. Or let's write a simple form this time. We can say sum equals sum plus I. So sum, this sum on the right, is the current value that is inside the box. We add to that one the new number that we are iterating, and we are placing the expression, the result of this expression is the box again, right? And we let the program do its things for 10 times. And after the iteration finish, so after this for block finishes, we go and inspect the box. We open the box. Let's see what's inside the box. So we display here sum. Let's run it. And it says 45. If I'm not mistaken, the sum of number from 1 to 10 should be 55. There is even a formula to add the first with the last and divide by 2. But the reason is 45 is because we are not including 10. If we want to include 10, we should put here less than equal to 10. So 10 will be considered as well in the iteration. And if we are running, yes, now it's 55. All right, so perhaps we should draw these boxes here on the paper just to better understand what I meant by that sum box here. So we'll switch here to the paper, and we first created a box, and the box was named sum, and inside we placed 0. And then what we did, we iterated through all the numbers from 0 to 10. And the way we iterated and we produced these numbers using a for loop, right? So for each of these numbers, at one point we have a counter here, basically an I, that initially I is 0 and then it goes down and I becomes 10. Inside here, what we are doing, we are opening the box and we are looking at the sum. So we read sum, right? We read sum. When we do sum plus I, we basically add I to sum. And we have it like a temporary value, and then we take sum and put it back in the box. So when we write sum equal sum plus I, so sum plus I is the addition that we did above, and when we assign it back to sum, we are putting back the sum in the box. So we saw this form yesterday when we said that basically when we assign a value to a variable, we can assign even its previous value. So we can assign, obviously you can say sum equals 0 like we did initially, but we can also assign its own previous value. So what we are doing inside the loop, we are assigning its own previous value, and we are repeating this 10 times. Initially I is 0, so basically from a sense it comes like this: sum initially is 0, and we are doing sum equal sum plus 0, and then sum becomes 1, or I becomes 1, so sum will be sum plus 1, and then becomes 2 and will be sum is 2, and goes up to 10 here. So who is making this number 0, 1 to 10? Well, the for loop. If we remember, when we displayed initially the numbers, for loops helps us iterate through a series of values. In this case, we iterated through this series of values, but instead of displaying them on the screen, we are adding them to the sum, and sum progressively grows. So as a matter of fact, if we go here inside, so I'm gonna show you something. Let's look in the internals of how this addition happens. Instead of displaying the sum at the end here, and actually we can display the sum at the end here, but we're gonna display something else. We're gonna put a println here inside, and we're gonna display sum here. And this is a pretty neat technique because it allows us to inspect the sum value as it grows, right? So we expect the println also to be displayed 10 times because it's inside the body of the for, and then we expect to find another sum at the end. So maybe this one, just to differentiate it, we should say sum equal, and the other one will be just a series of numbers. So let's run them. All right, so we don't see just this one, we see also the intermediate values. So basically this is the box, initially 0, and we add to the box 1. Now box is 1, and then we add to the box 2, so box is 3. Then we add to the box 3, so box is 6, and we add 4 to the box, so it's 10. And we see as it's growing, and the final value is 55, and at this point the for loops finishes and it goes outside, and we display this line ourselves. So this line inside was displayed 10 times because first of all it was placed inside the for loop. Second, we saw those numbers in a growing order because we are displaying the sum as is composed. So we saw initial sum, which was basically 0 because sum was 0, and we added also 0 on top of it, so it was 0. And then when I become 1, we added to that 1, and so on. Let's display as I as well. So perhaps we should display I as well, maybe separate them like that, I and sum. And actually let's put some text just to differentiate them a little bit. So maybe you should say I is now I, and then put some text here. and sum is sum. Let's run it. All right, now we can see it better, what's happening inside that for loop. It says I is now 0 and the sum is 0. I is now 1 and the sum is 1. I is now 2 and the sum is 3. So basically it's continuously adding into that box, which is sum. And here is basically these messages are displayed from within the block of that for. And when the for finishes, we are displaying the final results, which is actually sum. Now, this is considered like a debug technique, because if things they don't get right for the first time, maybe you want to inspect inside the for. This for happens so quickly, this repetition is happening so quickly that we don't get the chance to see what's inside. So a good technique is to basically place this kind of debug messages and trace the execution in a sense to see what is the partial result until we reach the final result. And once we are happy with how the program runs, we can remove this line, or in this case I commented out, and I'm gonna run it again and we just see the sum, the final result here. All right, so let's make use of the const variables a little bit here, like yesterday. So probably, let's say we want to calculate the sum of number from 0 to 10 and have 10 in a constant. So we can have const n equal 10. So let's say here, calculate the sum of numbers from 0 to n. We're gonna even put a comment here, change n value below and run the program. And then we have this n like a constant. And instead of going up to 10, it goes up to n, right? So I said change. How can we change a constant? Well, we can change it as a user. We can edit the program and change it. The program itself, the code, when it runs, cannot change it. But as you can see in this code, we don't have the need to change the value of n. So let's run it. Runs 5. Let's put here n 100. So basically the sum of number from 0 to n, basically from 0 to 100, should be now 5050, which is correct. All right, let me share with you this small code. As you can see, we are getting closer and closer to do some real world programming in JavaScript. So sum of, what did I write? Sum of numbers from 0 to n, and I'm sharing the link there. It's also, pretty important to remember this accumulation technique is quite often used in programming. Here I did a sum. Let's do factorial. Factorial has a similar algorithm as summing, but with factorial, and if as a refresher, factorial is basically the products of numbers from 0 to a certain number. Let's write down that formula before we actually write the code. So if you remember, so factorial, let's say we want to calculate n factorial. Of course, we're gonna choose maybe 10 for n. So n factorial is 1 times 2 times 3 and so on times 10. So we already see from here that we can make use again of a for loop, and the main idea is to iterate through numbers from 1 to 10 and then multiply them together, actually multiply them together. And the way we multiply them together, we're gonna do the same algorithm with sum, but in this case we're gonna start with a product variable, and this product variable will have the value 1. Cannot be zeros in case of sum, because 1 is the neutral element for multiplication. And then in a loop, what we plan to do in a loop is to multiply this product. The preview value of the product, we plan to multiply to it the current I that goes in here. So basically this loop will go through all the numbers. So the product will be, first of all, it will be 1, then it'll be 1 times 2, then this value will be 1 times 2, the one that was before, will multiply by 3, and then we'll go by 4, and so on. and after 10 numbers we'll have the product of numbers 1 to 10, and here the for loop finishes and we can display the product equal, and we're gonna display it. So this is the algorithm. Again, is the same as the one with the sum of numbers. And algorithm is a fancy word for saying how we plan to build this program, how we plan to instruct the computer to execute instructions in a certain order in order to accomplish the task. So we have this program. This was, let me put a name to it, sum of numbers, before closing it. We'll save it, and we start with a brand new code editor page. So, all right, so we have to calculate here factorial of n factorial. Actually, we want to calculate n factorial, which is basically factorial of n. And let's define n as a constant. So maybe we want to calculate 10 factorial. So let's have this n in a constant, also to get a chance to play with the constants a little bit. And the way we said we're gonna do, we're gonna iterate all the numbers from 1 to 10 by 1. We put here plus plus. And notice we are not starting at 0, and it would be terrible if we start at 0, because we'll have a 0 that when we multiply with 0, everything will be 0. So we start at 1, but we go to 10 and we increment by 1. And for each of these I, we multiply it to a product variable. But before then, let's just print line. Let's display again I. And we go up to n just to make use of variable, otherwise this line would have been useless. So let's make sure we are iterating correctly to the numbers. I'm running, yes, these are the right numbers that we are iterating, and we want to multiply them together. So the way we're gonna do, we'll have a variable here. Let's name this one prod, from product. This has initial value of 1, and instead, inside of for loop, we'll say product equal the old value of product multiplied by I. And again, I initially is 1, and then I goes 2, and so on. And at the end, we can here display println, and we can put also a nice label in front, and we can say n factorial equal, and then put the product, display the product. And if we run it, we also left that print inside is displaying the numbers, but we see the final result. Let's make it a little bit nicer. Let's remove the instruction inside, and instead of n factorial, let's actually display here the number 10 factorial in this particular case. So we remove n, we put the n outside of the quotation. So when it was inside, n was just a string, a text. So we displayed the text n. Now we placed it outside, so println will display now the value of n. Let's run it. So 10 factorial, see, we don't have an n, but actually the value of it is this value. And actually I don't know this one. Let's calculate it really quickly with Google. 10 factorial is 3,628,800, and if we switch to our code, it's exactly the same. All right. So we're already doing math, pretty complicated math with our computer here. We're calculating sum of numbers, we're calculating factorial, and all with the help of a for loop, a simple for loop that as I mentioned, just remember the form of it, just write it down exactly like it appears here, and later on you can rationalize the different parts of it. So this is basically, okay, let's put a label, and this is factorial. Let me share this one with you as well, just in case you want to run it on your side and play with the program. So let's say factorial of n, and I'm gonna share the program. If you click on the link, it will open on your side and you can have fun with it. All right, what other better way than understand for than to do more practice And of course, you can practice on your side, but let's do a little bit more practice on together here. So let me think of another exercise here. Yep, I'm thinking of one that is good if you have first graders or second graders at home. So let's display multiplication table with a certain number. And you know, multiplication table, like maybe with number 3 to say, or number 2. So it will go like that. 2 times 1 equal 2, 2 times 2 equal 4, 2 times 3 equal 6, and so on. We can go up to 12 or up to 10. So this will be the multiplication number table with 2. So let's put a comment here, display multiplication table with n. So let's define as a constant n. Maybe we want to display, and this will be the n, the constant. And then as you can see here, we have to iterate through numbers from 1 to 10. Let's say choose 10, not 12 or 10, it doesn't matter. And then calculate, multiply them together and calculate them. So the way we did that, of course, we're going to use a for loop. So we're going to say for, let I equal 1, I less than equal to 10, I plus plus. So again, refer to those forms. We want to iterate through numbers from 1 to 10. We have inside the for loop access to this variable I. So what we're gonna display is println, and we can display first of all n, which is this number. Let's display also this star, and this is just a text, but looks good for us when we're gonna read it back. So it's a star, the second piece of println. Let's display now the actual I variable here, value here. Let's put another string, and inside this string we'll put a equal sign. And then we have to display the result, which is actually n multiplied by I. And this is a calculation this time. The computer will do it in place and put here basically the result. And let's run it. See, that was easy. Now, if we want to just make use of more variables, we can just say like that, let product equal n times I, and here we can put the variable product, just to practice a little bit more variables. And here it is. All right. So I'm gonna save this this one as well, and I'm not gonna share this with you. It's just as a practice. It's very simple. Try just to recreate this exercise yourself. But now instead, I'm not finishing the stream, but instead I plan to see how to use for loops in context of graphical shapes. Let's do some nice drawings with for loops. All right. Let's go on the first page here. Oh, let me put a name to this one. So this is multiplication table. Sorry about that. I want to just to keep a record of all these programs. And now let's do some nice drawings using for loops. And do you remember the first instruction that we typed together? That was a circle, and there was a circle in the middle of the screen at coordinates 400, 300 and radius 300. Well, this draws a circle. What about drawing a few concentrical circles? I think we did that together last time, and the way we did it, we just duplicate the instruction a couple of times and just decrease here the radius, just like that. And of course we expect to see 4 circles here, but what about if we want to just create many circles till here, till in the middle of the screen? Obviously it's not a good practice just to duplicate these instructions, and besides, right now we have another tool in our toolkit, which is a for construct, which allows us to repeat things. So let me remove this one and place the for instruction, a single for instruction, inside the for loop. So let me build a for loop around it. So, and we want to just the radius to basically vary it. So basically this is the radius r, right? So perhaps we should have a variable r, that goes from 300. Initially the circle is 300, and let's make it go down this time. R greater or equal than 0. It's running as long as greater than equal than 0, and then R minus equal 10. Let's go down by, oops, let's place the circle inside, by 10, right? So, okay, let's analyze again what we wrote here. We have a variable R that starts at 300 and goes down to 0 and goes in steps of minus 10. So we should see basically some concentrical circles. If we run them, we see them. And let's name those on circles. And I'm gonna share the code with you. It's amazing what you can do with a simple instruction and a few geometrical shapes repeating themselves. You create these nice patterns. Oops, circles. Okay, I put there the link to this program in the chat. And you can play with it. So perhaps, you know, what about if we want to decrease the radius by 5 pixels instead of 10? We should have, you know, more dense circles. And actually, let's decrease it by 1, and you'll see something interesting here. Okay, so why we don't have a black circle? And the reason we don't have a black circle is because the entire canvas and on the computer itself, the canvas is a discrete space, is not continuous like on paper. So this, remember, we have all these pixels, right, that get set or set to various colors, and the algorithm for the circle just sets these pixels, and sometimes pixel gets not set, and or between two circles some pixel they don't get set, and they create these moire patterns, this kind of interference pattern here, and we see like that. So we see them only if we are decreasing by 1. Let's see if we see them if we decrease by 2. Still we have a little bit of interference or a little bit of effect here. But once you go, let's say if we decrease by 3, this starts to disappear slowly. And when we had by 5, we didn't have them almost at all, right? So let's leave them by 10 here. But of course, play with this one. So that is an interesting example here with circles. Let's do more. Let's do more graphics with 4. Let's draw this time some lines on horizontal, and let's draw first line just to have it like an example, and then we'll multiply this one. So let's say we draw a line that starts at coordinate 0, 0 and goes on the entire screen. So the length goes to 800 on horizontal but 0 on vertical. Lines, we have to specify the coordinates of both ends, not the width and height. So see, we have a line here, and if we want to draw now another line below it, basically we can, again like we did before, we duplicate this one. So let's say we don't change the x, or we don't change the x coordinates of either end, but we change the y coordinate. So here, if we have it to 10, we should have second line at 10 pixel below. So let's use this technique basically, and just duplicate this line using a for loop. So we're gonna just say a for, and let's pick another name for the variable. And since we are varying the y, let's pick y. For let y, it starts at 0. Y is less than, so this will work as long as I is less than, well, less than 600, because 600 is the last coordinate on the canvas, and then I plus equal 10. And let's have this line, line, place inside the for loop. Let's run it. Oops. Oh, of course, we didn't make use of the y. So what we did here, we used that first form. We're just repeating this line like many times, but in the same place. So the computer is actually drawing not one line, but many lines, but at the same coordinates. So that is the reason we see just one line. But if we vary here and make use of the y coordinate inside, these lines will be drawn at different coordinates. And as you can see, we have multiple vertical lines. What about creating some squares? So let's create also a series of lines that go on horizontal here. So that's very easy. We can say for, and since when they go on horizontal, actually we vary the x coordinate, right? So let's pick a variable named x that starts from 0. X will be less than 800, and also we go by 10. We incrementing by 10, since we want to keep the same square size. And then we have a line. Now this time we want to draw vertical lines, right? So x will be the one that it's varying. The first y sits at 0 for all the lines, and then they go also x, and the second y sits at 600 for all the lines. All right, so let's run this, and we see some nice squares here. All right, so maybe we should have this 10 like a constant. Let's name this one. Let's say we have this one const square size. It's 10. And instead of having here 10, we increment by square size. And notice, yes, when you increment, when you use this form of incrementation, you don't have to put actually here a constant like a number. You can put even a variable. It means y, oops, y is incremented by this value. That's the meaning of this one. And refer to the variable lesson if you want to refresh your memory. Let's run it again. It's exactly like before. If we increase the square size maybe 25 pixels, we have bigger squares. If we increase to 50, we should have even bigger squares. And let's make this 2. A very fine grid paper kind of mesh here. Let's put 10 back. And we have here squares. So these are squares. Let's name this program lines. Actually, this is just lines. But they make up squares. The pattern is make up squares. And we created them with 2 for loops. All right, it runs perfectly. I can also place this program in the chat for you to further inspect it, extend it, modify it, play with it, understand it. Lines. So basically this is for squares. All right, the program is there in the chat. So as you can see, we have again just one observation here. The 2 for loops are one after the other. We'll have soon a lesson when we're gonna see that we can place fors inside fors. Those are called nested fors. This one are not nested fors, are just one after the other. And let's run it again. And actually, let's comment the first for to see the execution of only of the second one, because we didn't see it. So these are the vertical lines. So basically, oh, let's put a comment here. These are vertical lines. And the other one is doing horizontal lines. All right, so I uncommented them both, so we should have them both, so we have these squares again. Okay, 2 more exercises today. I'm thinking to do something a little bit nicer. So let me quickly locate here. Yep, this one. Yeah, this one. Remember when we draw this car using variables? I think it was in the preview lesson. So let's do something here interesting. I'm gonna save a copy of this one, and I'm gonna name it cars. And the name should give you a hint. We want basically to draw not one but multiple cars. And I think we are in pretty good starting point here, because we already have the ability to control where we display this car on the screen by modifying these variables. So what we want to do is perhaps let's display a couple of cars on horizontal. All right. So one way of doing it is to place this entire block of code in a single for loop, just to show that basically there's no limit what you can place inside the for loop block. So we're gonna wrap all this code with a for block. So we're gonna, and let's display, really interesting. Instead of varying the, so we want to display them on horizontal, but instead of varying here x, like we did in the previous exercise with the lines, instead of varying x or y inside the for, let's use here a simple counter for the number of cars that we want to display on horizontal. So let's say I want to display 5 cars. So we start with 0. Oops, and I think we don't see pretty well, so let me magnify it. Okay, we start at 0, we set 5 cars, right? So I less than 5, I plus plus, and we start the block. And now look what I'm gonna do. I'm gonna move all this code that is outside inside the block. And each time we have a code inside the block, it's also, as you saw me before, it's also good practice to indent this code a little bit, just to indicate. Again, it's totally optional. White spaces are not considered by computer, but for us humans, it's much easier to basically see that this code is inside the code block. And I'm gonna make here a parenthesis as well about the position of the curly brackets. As you can see, the position is here at the beginning and at the end. And I think this form of placing curly brackets, it's best for beginners because it's very easy to visualize a code block. So this is a code block. You can see it's a perfect square. Some other JavaScript developers prefer to place the curly bracket here at the end. So see, instead of being here, it's placed at the end. Again, it's syntactically is the same. In JavaScript, these white spaces, even if I leave here multiple enters or multiple spaces, these white spaces, they don't have any effect. So by just placing the curly bracket here, it's the same basically. So some people prefer it to place it like that, and most of the most advanced developers are actually placing it here. But I think it's a little bit not intuitive for beginners to see it here. It's much easier for beginners to see the curly brackets open and close at the same level. So since this one is closing here in the beginning of the screen, let's have the other one on the other line as well. So at least we can see them opening and close on the same level. So it's here in the beginning, they just go straight down, and here it's closed. And everything that goes inside the code block is identity to the right. So it's now very, very clear that this is a for block. Okay, so we want to repeat this 5 times. So I place this inside. Notice we are not yet making use of the I variable, but let's run it nevertheless. And maybe you can see the lines a little bit thicker, and that's because we are just displaying the car 5 times over, but we want to display it in different positions. And the way we're gonna do that is to vary the x, and instead x of being 10, we want to make it somehow dependent on I. So the first car perhaps to display it at coordinates 10, the second car to or let's say 0, the second car to display it at coordinates 100, the third car at 200. Yeah, let's increase it by 100 and let's see how they look like. If not, we're gonna make more space between cars. And the way to do that, we can say x equal I times 100. So because when I is 0 is 0, when I is 1 is 100, and so on. So let's see how it looks like. They are squished together. I think the cars are bigger than 100 pixels, so they start to overlap. So let's multiply here by 200. Yes, it looks better. Let's multiply here by even 220. And looks a little bit better, but we have a problems because the maximum horizontal resolution here is 800 pixels, and 5 cars just go outside of the canvas. So we can leave it like that just to see that what is not visible, it's basically, it's outside. So see, we just repeated this car several times on horizontal. It's still not an animated car. We're gonna talk about animations in a future lesson. We're gonna make the car vroom, go from left to right. But that's a little bit, like I mentioned, it requires a different technique. This is just a static picture in which we basically repeating the drawing of the car. We render it in a matter of speech 5 times on the screen here, and all using a for loop here. And the different thing from the previous example is that in this case we'll use an I as a counter for the number of cars that we want to display. rather than for the x, and we modify the x starting from the counter. So let's put a comment here, display car, display a car n times, and perhaps let's choose some constants. Perhaps we are not yet ready with the exercise. Let's choose a constant. So let's choose a constant n, which is 5 times. So basically here it's n. Yes, it's the same. What about if we define a constant size, or size factor? Let's name it size factor is 1. And what we want to do is basically this width and height that we have inside, let's multiply to this size factor. It's to make the car a little bit bigger or smaller. So let's try to multiply it here with size factor, the width and just the height, just these two. One is obviously should look the same, but let's try to put here a 0.5. Now we have smaller cars, and now we can fit more cars on the screen. So, alright, so perhaps here we should not, well, we know already the width of the car is this one, W. So perhaps here, let's move this one down. We'll move them after we have the constants ready. So width is the width of the car. So instead of multiplying here with 220, let's multiply with width. And now we know precisely where to place the next car, but let's multiply it by width plus 20 to have a little bit of white space in between cars. And now we have them 5 cars on the screen. And I think we can fit even more if we put size factor here 0.3, and we can display 10 cars. Let's see, can we display 10 cars? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Precisely 10 cars on the screen. And display a car n times. Let's put a comment here. Change the values of n and let's just size factor. Okay, size factor to control. Yeah. Change the values. We just put a comment here to indicate to our future self, or in the future we're gonna read again the program, or maybe to a friend that we're gonna share this program, that they can play with these two numbers in order to have more cars or less car on the screen, and also to make them bigger or smaller, right? So here it's size of the car, control size of the car. We put a comment here, and for this one we comment it and we say how many cars we draw. All right, and I place these comments to the right this time. Let me save this one and share it with you on the chat. So I'm running, looks perfect. And I think it's, you know, this exercise is a culmination of variables, drawing, shapes, for loops. We just don't have colors here, but we can add it very easily. So let me place this one on the chat. Cars. And I don't want you to be discouraged. This program looks a little bit big. But in the future, when we're gonna learn new techniques on how to modularize the code, using new concepts such as functions and things like that, this code will be simplified and can look pretty beautiful and easy to read. But with what we learned until now, I think we were doing pretty good here. All right, let me do one more exercise and then we are done for the day. And let me start a new code editor. And you know what I want to do? I want to place some bands of colors, of different shades of color on the screen. So the way I'm gonna place a band of color, I'm gonna use the rect command just to place a tiny rectangle on horizontal. So perhaps it starts at 0, 0, this rectangle. It has the width 800 and the height is 20. Let's play with it. Yeah. Let's take as a constant here let or const band size is 20. So this is band size actually. All right. And now we want to display multiple bands. We're going to use a for loop. The question is, how many bands can we fit on the screen? Because when we do the for, we have to go from a value to a certain value. So the question is how many bands, but we can calculate that pretty easily. So we can say also as a const, we can have it number of bands equal, it's 600 is divided by band size, right? 600 is the horizontal resolution and divided by band size. And you know what may happen? These numbers may not be whole numbers if we don't have here. So we'll see what it happens and we'll handle it back then. But in case of 600 divided by 20 is fine. So let's do now a for loop and say for let I equal from 0, I goes to number of bands. So I will be a counter variable that basically it's represent the band number, and then I plus plus. So we are drawing this number of bands. We are drawing at the same position currently, but let's, and if we run it, we'll see it in the same position, multiple bands. Let's print it. You know, I'm curious, but actually we can calculate it. We can put a println instruction here to see how many. So we are 30, yeah. So I plan to display 30 bands. So, so if we just run the program like that, we'll have the same rectangle display 30 times in the same position, but we want it a different position. So we want to calculate the Y of the other band. So the first band is band 0, the next band is band 1, the third band is band 2, and so on and so forth. So Y basically is, the first band starts at 0, the other band should go exactly below it. So basically, if the band size is 20, the other band should go at 20. And then because the band is 20 in size, the band below it should be 40. And then the other one at 60, the other one at 80, and so on and so forth, until we finish all the bands. So we can basically see the pattern here. So Y will basically be band size multiplied by I. So let's see it. Boom. Oh yeah, because we are not making use of Y. So it starts at 0, it's Y down, and then 800 width and band size height. Boom. We have multiple bands, but they are all white, so we don't differentiate them. So let's make them different shades of color. So bands of color. Let's them, and if you remember, to fill the rectangle with a color, we can use the fill command here, and we can use, just as a small recap, we can use one of these named colors, but I don't think that's a good idea because we cannot loop through these ones with a counter like that. The second, we can use that RRGGBB form. So basically an RGB color specified in this format. But there is a third form for the fill that we didn't touch until now. Basically, it's similar to this one, but the RGB values, you can just specify them like that. Just plain values. And yeah, and we're gonna use this form. So we'll pick a color, maybe red. We're gonna keep constant green and blue, and vary red from 0 to whatever other number it is, right? So green and blue, let's keep them constant at 255. We saw last time, if we have all the three numbers 255, basically we should see white. And if we have this number like in between here, we should see that particular color. So let's see it here. No, the other way around. If we have all numbers as 0, we should see a black. And if we have this number, a number in between, or the last value is 255, we should see that particular color. It's like, if you remember those LEDs inside each pixel, is like we are turning off the green and blue LEDs and we are cranking up to the maximum the red one. But we don't want to have just the same shade of red. We want to have different shades of red. So here we should vary the shade. So this is R that we want to vary. So let's have it a variable R stands from red. We can even name it red if we prefer, or just let's have it R. It's not radius like in the other examples. And this one will start with just being R being I. I don't think it's nice. So I will go from 0 to 30. So we'll have 0 to 30, we have very dark black. Let's make it jump a little bit, maybe jump in steps of 10. So if we multiply by 10, then should be when is I0 is 0, when it's 1 it should be 10, and then should go 20, 30, should go like that. Red should go in this progression, and we already start to see it starts at 0 here, which is black, and then goes towards red. So the last one will be here when it's 30. This one will be 300, actually goes above 255. So if I'm looking correctly, I believe the last two bands here are the same shade. We can have a way to make it stop at 255, but it doesn't matter. Apparently it handles it successfully, even if we have it go beyond 255. So this is with varied red, but let's maybe name this color C, just color. Color. And here's the thing. I mentioned that you can name the variables whatever you want, just don't start them with a number, don't start them with a certain symbol. Also, there are some reserved words. We cannot name a variable with a reserved word, like let, for instance. We cannot have a variable let. And also, I don't want to name it color because there is another entity named color. Probably will be okay in this case, but it's best to avoid naming variables with the name of existing entities in the system. And if you don't know about it, don't worry, just name it and you'll get an error and you'll fix it. So there's not a problem, but I'll just name it C or CLR from color. Just let's name it CLR. And we'll place it on this position. We should see bands of red. What about if we play the CLR here and left here 0? Well, we see shades of green. And let's finally place the CLR here and see shades of blue. And now, of course, you know what? Feel free. You can place them. You can vary two kind of components of the color, red and blue at the same time. What we'll get? This purple color. And if we vary all three of them, if they go the same, we said if they are the same, these are shades of gray. So as you can see, these are shades of gray. So they are not too spectacular. So let's leave this one turned off. And now we get another shade here. So yeah, feel free to play with this one. Let me put CLR here, and here is 0, and this is 0. So yeah, we have shades of red again. Let me save this one. This is called bands of color, and it's achieved using some simple rectangles that are filled with the color, and all these are repeated a certain number of times on the screen. All right, so let me share this program with you as well. And play with these programs, see the other streams before this. If you have any misclarification, of course, put comments in the chat. If you have a question, also during the live stream, I'm always encouraging you, even during the live stream, if you have a question, put a question there in the stream, and we can answer the question during the live stream as well. And or shoot me an email if you have, and if you want to chat with me at any time. All right, so this was the last exercise that I kind of intended for today. I hope that although we went over a very lengthy explanation for 4, I hope that in the end, through these examples, now 4 makes sense. Remember, there are 5 forms of 4 that is good for you to write them down and reference to them really quickly in case you want to go them. So basically, there is a form just if you want to repeat certain things a number of times, and you don't care about the counter variable, you just want to repeat a block of code several times. It's not that used very often, this form, but sometimes it's useful. Second one, if you want to iterate through numbers from 0 to a certain number, Or even we didn't look here at any example, but you can iterate from numbers in a range, not from 0, starting from a certain number. But anyway, iterate through them with a step of 1, then iterate them with a step bigger than 1, then go in the other direction, go towards 0, and then go towards 0 with a step different than -1. So these are the kind of forms for for that if you master these forms, you can do pretty interesting things, such as we did here. You can display things, you can do sums, you can do factorials, this kind of mathematical operations where you cumulate the result of these numbers, and then you can use them for graphical effects. The one that we did today are this band of colors. We play with that car on the screen. We duplicate it a certain number of times. We did the lines on horizontal and vertical. We did the circle. Of course, also we did today the multiplication table. So refer to these programs, and I hope that your library is growing as well. This is my library of programs, starting with the very first program that we did together last week. And until now, we have quite a collection of programs, and it's still growing. So thank you very much for watching. Happy coding, and see you next time.